Welcome to mechanical engineering students. Today we are continuing mechanical measurements. In today's session, we are going to discuss gauges, that is purely limit gauges, which are used for mostly inspection purpose. Then we are going to study plug gauges, which are used for checking the holes. Then ring gauges, which are used for checking the shafts. Then the snap gauges, which are used for checking the external dimensions. We will see one by one. So what are gauges? Gauges are not the instruments where you can measure the dimensions. So they are scale-less inspection tools used to check the dimension of the parts. So in gauges, you are not making use of the scales. That means you are not making the measurements, but they are the inspection tools. Basically, the gauges, they do not determine the actual size or dimension of the part. They are also used to check whether the inspected part is within the specified limits. So to summarize, what are the gauges? Gauges will tell you whether the components manufactured are accepted or rejected. So with the help of gauges, you can directly tell whether the components are accepted or they are rejected. So we will see one by one. This is the limit gauge for hole. So this is the diagram of the workpiece with a hole in this. So we are studying how to inspect this hole with the help of a plug gauge. So here you can see there is a maximum limit size for the hole and there is a minimum limit size for the hole. You can see this is the minimum limit and this is the maximum limit. So what this gauge will tell you is whether this hole in this workpiece is accepted or rejected. That is determined by this plug gauge. So in the limit gauges, there are go gauges and no go gauges. What this go gauge tells you is if this go size goes into this hole, then the component is accepted. If this no go gauge goes into this, then the component is rejected. So the go gauge will check the minimum limit size for the hole. So the go is set for the minimum limit size for the hole. If this go enters this hole, then this entire component is accepted. If this go doesn't go here, then it is rejected. Similarly, if the no go size, if that goes through this hole, then the component is rejected. So it is as simple as that. If the go gauge enters, it is accepted, otherwise it is rejected. So this is the diagram for the plug gauge, which is used for checking the hole. This is the workpiece. This is the workpiece, and this you can call it as a hollow workpiece. Here, this is the dimension of the hole. Now, where these plug gauges are used, the same diagram we can see here. The limit plug gauges are used for checking the holes. In that, go plug gauges will check the lower limit, that is minimum limit. of the hole. And the no-go, this no-go will check the maximum limit of the hole. So Taylor principle says that the go gauge will correspond to maximum material condition and no-go gauge will correspond to minimum material condition. In case of holes, the go is checking this minimum limit in case of holes. And in case of no-go, it checks the maximum limit of the hole. So all you have to remember is the Taylor's principle, which tells us that the go is designed for maximum material condition. What is the maximum material condition for the hole? It is the minimum limit size. Now we will see the three-dimensional object for the holes. Here you can see it is a double-ended plug gauge. This is a double-ended plug gauge. That means the go is here, go gauge is here, and no go is here. And this one is the workpiece. So how to check it for our inspection purpose? You can see that no go end is not going into the component feature. No go end is not going into the component feature. If it goes into the component feature, then this component will be rejected. Similarly, the go end goes into the component feature that is being checked. You are checking this feature, this workpiece, and there is a hole here. If this go end goes through this, then the component is accepted. That you can see here. The go end has gone into the component feature that is being checked. So in the previous, you can see the no go will not go into the, it is not supposed to go into this hole in case of plug gauges. No go should not go into this. If it goes into this, it is rejected. Then go should enter this component feature that is shown here. The go part has gone into this component. Now it is accepted. So you can appreciate the fact that without measuring the actual dimensions of the workpiece, you are classifying the components as accepted or rejected. That is the advantages of these gauges. So you can check the many types of gauges. Again, continuing with the progressive plug gauges here. Progressive plug gauges. So these are nothing but the gauges with go and no go type. This go and no go type. They are arranged in same side of the plug. That is why it is called progressive plug gauge. They are arranged on the same side. Then we can use these plug gauges progressively one after the other while checking the hole. Then go end is made smaller than the no go end. This go end is made smaller than this no go end in the plug gauges. So the same thing can be seen here. This is the progressive plug gauge, three-dimensional drawing. It is used for checking the diameter of the straight hole. So you can see go and no go on the same side. Hence it is called progressive. So here it is mentioned clearly, and here up to this part it is go and this part it is no go. So progressive plug gauges are seen here. Then this is single ended plug gauge. So go is on one side, this is the go part, and here this is the no go part. This is the workpiece or component. So single ended plug gauges, both are on the separate sides. Now we can go for ring gauges. So to summarize the plug gauges, how many types of plug gauges are there? I will come back. In plug gauges, there are basically three types. One is a double-ended plug gauge here. Double-ended means go is here, no go is here. So what is this double-ended plug gauge? Go and no go end are arranged on both the ends of the plug. Go is arranged here and no go is arranged here. It saves the time and it facilitates the easy handling. So one of the types of plug gauges is double-ended plug gauge. This is the double-ended plug gauge. So to repeat what we have learned, this go should go into this hole, the component is accepted. This no go should not go into this hole, then also component is accepted. So double-ended plug gauge. Then there is progressive plug gauge, which is here. Then there is single-ended plug gauge. So in all these three types, that is double-ended plug gauge, progressive plug gauge, and single-ended plug gauge, we are checking the hole size. So for go size, we have to check the minimum limit of the hole, and for no go gauge, we have to check the maximum limit of the hole. Now we will see the limit gauges for the shaft. These are called as ring gauges. You can see here, this is the shaft and this is the maximum limit size for the shaft, and this is the minimum limit size of the shaft. So from Taylor's principle, the go should check the maximum material condition. So this is the go. This is checking the maximum material condition. What is the maximum material condition for shaft? It is the maximum limit size. And for no go, it is the minimum limit size. So we will see the three-dimensional diagrams of the ring gauges. Again, in these ring gauges, the whole of the go ring gauge is made to the upper limit size of the shaft and no go for the lower limit. When we are checking the shaft, the go ring gauge will pass through the shaft and no go will not pass through it. That can be seen here in our diagram here. So what are these gauges for shafts? They are called as ring gauges. Checking the shafts is done by the ring gauges. What are these ring gauges? You can see here there are separate gauges. One is a go gauge, the other one is a no go gauge. They are the separate gauges used for checking the external features. So there are separate gauges here. In case of, you can see here in ring gauges, there is one separate go gauge, there is one separate no go gauge. Then this shaft or component diameter we have to check. If this go gauge goes into this shaft, then the component, this component is accepted. Then if this no go gauge does not go through this, then this component is rejected. That we will see here. You can see this is the GO gauge, which we have seen in the previous slide. This is the GO gauge. The same thing is here. This is the GO gauge. The GO end should go into the component being checked. This GO end should go into this component which is being checked here. Then if it is no go should not go into the component that is being checked. Okay. Now, before we go to the snap gauges, you should understand ring gauges. What are ring gauges? They are used for checking the dimensions of the shafts here. Okay. So there are separate gauges here. For the ring gauges, there are separate gauges here used for checking the external features. Okay. So what are the points to be noted here is GO will check the maximum limit size of the shaft and no go will check the minimum limit size of the shaft. Now the same thing, we will now concentrate on the snap gauges. What are these snap gauges is shown in the diagram. In the snap gauges, it is used for checking the external dimensions. External dimensions are checked using the snap gauge. So this is the workpiece which we want to check and inspect. And this is the go part. This is the no go part. So if this component goes through this go part, then this component is accepted. If it doesn't go through this no go, then also it is accepted. So very simple to understand these gauges. So as we have said, the gauges are not measuring the actual dimensions of the components. We are only classifying the components as good components or bad components by using all these types of gauges. So the snap gauge diagram, how it is inspected is shown in this diagram. The go end, this is the go end, which was shown here as this go end. So that same is shown here. This is the go end. It should go into the component being checked. So if it goes into this component, then it is accepted. And the no go end should not go into the component that is being checked. Okay. Similarly, we have the adjustable snap gauges. You can see the adjustable snap gauges, which is another name for this is caliper gauge. Another name for this is called caliper gauge. So these adjustable caliper gauges can be used for checking the external sizes in any place along the length of the work. So this length you can check here. The diagram shows one is this green button, the other one is red button. Here by screwing this, we can adjust for the go size, and in the red side, red spot, but if you screw this, we can adjust for the no go size. So adjustable snap gauges are used for checking large size shafts made with horseshoe shaped frame of 1 inch section. It has one fixed anvil and two small adjustable anvils. The distance between the two anvils is adjusted here by adjusting the adjustable anvils by means of the screws here. By means of screws, we can adjust the distance. This adjustment can be made with the help of slip gauges for specified limits of size. So we can see the slip gauges here. These slip gauges are used here, which are master standards of measurement. So this slip gauge will help you to check the dimension. So here you can see the go and no go standards with the help of slip gauges. If you measure here, it is go standard, and if you measure here, it is no go standard. So this is regarding the adjustable gauge. So these are the two diagrams for adjustable snap gauges. So to summarize, what we have learned in this session is, we have learned basically the different types of limit gauges. The different limit gauges are plug gauges used for checking the holes, ring gauges used for checking the shafts, and snap gauges used for checking the external dimensions. Then adjustable gauges, which is also known as caliper gauge, used for again external sizes. So this is regarding the gauges.